Hey, calculates, long time no see. So we've been working up all this information to prepare us to be able to sketch the graph. And so here are some things that you need to remember. Oh, look who's here, calculus kitty. Here's some things that you can do, basically kind of a checklist to help you be able to graph whatever your function is. So, of course, you want to identify the domain so that you aren't looking for parts of a graph that don't exist. You want to find the intercepts, of course, the x and y. You want to find any asymptotes that you have. And then you want to find the extrema. Now remember, in order to do that, you're going to use first derivative and set it equal to 0 or undefined. And then you'll find those values. And then last but not least, you want to find any points of inflection. And so to do that, you'll use second derivative. And again, set it equal to 0 or undefined. And then do your test of concavity to figure out if they're actually points of inflection. Remember, it's not just about setting it equal to 0 undefined. You actually have to do the tests. So I need to see the tables. So I'm going to give you a template that you can use that basically is a checklist of all the pieces that you need to fill in prior to sketching a graph of your function. So these are, of course, just basically a checklist in terms of what it is you need to have as part of all the puzzle pieces before you're ready to graph. Okay, so now I know some of you have asked about how do I find that slant asymptote. If you had me last year, and some of you did, but you forgot, you have this in your old notes, but I'm going to do an example because I know everybody forgets, and some of you probably haven't seen it before anyways. All right, so here's how I find the slant asymptote. So I'm going to use long division. Remember, this only happens when the degree of the numerator is 1 more than the degree of the denominator. And that's this particular case. So I am dividing. The top always gets divided by the bottom because this is the division symbol. And I'm really looking at how many times first term goes into first term. So if I need to, I come over off to the side and I check. Let's just do x squared divided by x. Oh, it simplifies to x. Okay, so now I know how many times it goes in, and I want to make sure I line things up. So x's line up with x's, so it will go on top. And then just like in regular division, I take this and I multiply by whatever's over here. So I would do x times x, which is x squared, and x times -2, which is -2x. And again, just like regular division, I would subtract. Now, just to make it easier, I usually turn this into a plus. Put a circle around it so I don't forget. And then I change all the signs. Just distribute the negative. And so I go, oh, that's going to cancel out, nothing there. This is going to cancel out, nothing there. And then I would drop down the next term. And where those nothings are, I don't usually put anything. So I scribbled there just so you know there should be nothing there. And then I check to see, will x actually go into 4? And of course the answer is no. So that would be my remainder. But the answer is everything except the remainder. So my answer is this, and it's y equals whatever this is. So my slant asymptote for this function is y equals x. That's how I find a slant asymptote. All right, so let's start with this next function and go through all of our checklist stuff. So I forgot it would be nice for you to have the template, but I think it would be better to actually fill this out in class. So that's the end of your notes for tonight. Hooray! We're going to do these in class tomorrow. See everybody tomorrow.